This problem is going to change up a little bit the style of questions we've been doing. Let's see how this one goes. You know, we can use different notations when we use the chain rule. We can use the prime notation. I like that. But sometimes it's more useful to use the dy notation. So we want to find dy dt. Notice y is a function of x and x is a function of t. So we could replace all occurrences of x by this formula here, and that would give y as a function of t, and then dy dt is perfectly defined. But the chain rule tells us that if we want to find dy dt, we can work as follows. Since y is a function of x, we can first do dy dx, find the derivative of y with respect to the formula with the variable x, and then afterwards multiply by the derivative of x with respect to t. That's the chain rule. Often we use different letters. You know, before I wrote dy dx is dy du times du dx. That was when y is a function of u and u is a function of x. But we have to be flexible and realize that we can use other letters. So in this case, our intermediate variable is not u but x, and t's are kind of like our final independent variable, and y is our dependent variable. So I hope this initial step makes sense. What is dy dx? Well, that's easy. It's 3x squared minus 3 times 1, which is just 3, plus 0. And what's dx dt? Well, 1/2 is going to stay, multiplied by, what's the derivative of root t? It's 1 over 2 root t, and plus 0. I won't bother writing that. Let's just clean that up a little bit. So dy dt is going to be, well, 3x squared minus 3 stays. And we could multiply the half times the half, so it's 1 over 4 root t. And why don't we just write this as a fraction without any brackets? So 3x squared minus 3 all over 4 root t. We could factor the 3 to the front, but that doesn't matter here. We want to replace t by 4 now. So this is the derivative. We're done the derivative, but often we want to evaluate the derivative at a certain number. In this case, we want to put t to be 4 in there. Well, we could easily put 4 inside here, but the question is, what do we replace x by? Well, that's not too hard, because when t is 4, we can find out what x is using this formula here. So why don't we do that on the side? So our formula for x, I'll just recopy it, is 1/2 root t plus 3. When I put t to be 4 in there, I get 1/2 times root 4 plus 3. And what does that give us? Well, root 4 is 2. 1/2 times 2 is 1, and 1 plus 3 is 4. So I know that when t is 4, x is also 4. And now I'm able to evaluate that. And remember the notation for this dy notation? The notation for putting in a number is like this. You write this line, and then you write the number below. It's kind of weird, but that's the notation. And let's make our substitutions now. What is x equal to when t is 4? We just figured it out. It's also 4. That's just a coincidence. All over 4 times root of t, which is root 4. So we have 12 minus 3, which is 9. And root 4 is 2, and 4 times 2 is 8. So our answer is 9 over 8.